In 2004, only 2% of the national forest acreage received some sort of treatment, mostly for fuels and weeds. In this national forest district, there are more than 40,000 acres for each full-time employee. There have been 4 rangers in 5 years. But on private land, timber production from well-managed forests often pays for the costs of management. Tree growth depends on water retention in the soil and on an invisible food web of microorganisms that recycle nutrients. Fire puts all this at risk.
I would be very, very, very careful about a prescribed fire. Most of them get away from them and do more damage than what they want to. They kill an awful lot of trees. It'd be better off to log and lop the sash or pile it.
I don't like fire. All we're seeing is what grows on top of the soil. We're not even thinking about what's under the soil. Mycorrhizae and things like that.
Mycorrhizae are fungi that form a sheath around the fine roots of trees. Both the trees and the fungi benefit from the relationship. Even in dry pine areas, nearly 200 species of mycorrhizae live in the top few inches of soil and organic material.
I dug down in this forest duff here, decomposed, rotting vegetation. This is the stuff that makes this forest function, that acts like a sponge for any moisture that falls on it, and it also keeps the ground shaded and cool in the summertime. It's just like putting a big insulation blanket over this ground. I liken it to a healthy skin. And when you burn these fires, you burn that off. That top 2 to 3 inches of accumulated duff over the last 50 to 100 years is not here anymore. This fire smoldered around and was hot enough that it took all of that material off with it. The ability for the ground to take on moisture is not here. And when you remove all of that, and then you just have nothing but the mineral soil sitting here, when a raindrop falls here, a good part of it runs off into your water drainages, your creeks, your salmon streams.
Half the dry weight of the forest is the element carbon, drawn from atmospheric carbon dioxide by photosynthesis. Almost all of this carbon will cycle back into the atmosphere in one of 2 ways. It can rot, or it can burn. The rot or decay pathway of the carbon cycle provides food and habitat for an enormous range of biodiversity. Almost all forest wildlife, as well as countless invertebrates and microbes, depend on these grazing and decomposing food webs. Decaying material provides a protective and absorbent cover for the soil. The fire pathway of the carbon cycle, though it does favor fire-dependent species, destroys habitats and food webs and often the organic matter protecting the soil. Fire releases dioxins, mercury, methyl bromide, formaldehyde, benzene, ammonia, methane, and carbon monoxide into the atmosphere, which in the decay pathway are held in the soil or rendered harmless. In the Pacific Northwest, biomass burning, whether accidental or intentional, is the largest emitter of atmospheric pollution and greenhouse gases. Fire releases carbon suddenly into the atmosphere, whereas the decay pathway holds it, sometimes for centuries. The fire pathway can also heat our homes and buildings or generate electricity. However, only a small percentage of the forest biomass that burns is now harvested for energy. The decay pathway depends on moisture. In the eastern United States, the humid summers favor microbial decay and fire is rare. But much also depends on human decisions. Many excellent forest stewards in dry climates promote decay of woody material by conserving shade and moisture and maintaining good microclimates and habitat for fungi, microbes, and the larger animals that break apart and shred woody material. Aggressive and unambiguous fire suppression prolongs the opportunities for decay. In most forest areas, we humans choose whether the carbon cycle follows the decay pathway, with all its benefits to biodiversity, moisture retention, and timber growth, or the fire pathway.
We want to have good habitat. We want a sustainable ecosystem. We want some economic benefit from the land. I don't think it's possible to have those things and have a fireproof forest.
When you're doing what's best for the timber, you're doing what's best for everything.
I logged when we just went in and got a log. How in the hell ever you wanted to get it, you went in and got it. You rooted and pushed and you made a colossal mess. These guys are a lot smarter. They've got a lot better equipment, and they're capable of putting a stand in any kind of condition you want it to be in. And you can't do that with fire. We're certainly not going to be able to burn our way out of our forest health problems. Good forest management is far more complex. The models for this management, they are working, and they are economical. If we're going to do anything in our national forests, we're certainly going to have to find a way to do it economically.